some transformations going on with these two functions, right? What do we call f of x, which is the general function? Do you guys remember what we call it? Parent, okay? Good. So now, everything that happens to f to the x, or 4 to the x is going to be part of our transformations. Does anyone see one of the transformations? Nathan?
It's horizontal.
This plus 1 is horizontal. Very good. Let's circle it. This is a horizontal transformation. Why is it horizontal? It's inside opposite world. Opposite world for exponential functions is where? In the exponent. Very good. So it's horizontal. Not a reflection, yeah? Not a shrink. Who said translation? Good, Eli. Why is it a translation?
I don't know. I was guessing.
Thank you for your honesty. Melanie? Because it's adding or subtracting. Very good. It's adding or subtracting. Anytime you see that plus sign or that minus sign, okay, it's going to be a translation. Miguel, I'm timing you, okay? It's a translation, but donde? Where does it go? We have to give it direction. This is to the left by 1. Why is it to the left by 1? Someone other than Gabby. Mariana. Yeah, buddy. It's in opposite world, okay? So, horizontal translation to the left by 1. Yes, it is difficult. But are we capable of doing difficult things? Yes, we are, okay? All right. What else can we do? What else is a transformation? The negative in front of the 4. I like it. Circle it. But guys, keep in mind, what's our base here? Just 4. The 4 is not part of your transformation. Only the negative sign is. What is going on between the negative sign and the 4? There is parentheses there technically, right? Because 4 is your base. What operation is there? Multiplication, okay? Now, let's ask ourselves, okay, it's outside opposite world, right? What are all transformations that are outside opposite world? They're vertical, okay? And they're in the real world, okay? So it's definitely vertical. And what operation, if it's multiplying by a negative, what does that mean, yeah? Excellent, it's a reflection. Okay? Anytime you multiply by that negative is out in front. It will always indicate a reflection. Now, let's think about this, guys. Here's my x and y axis. If you are vertically reflecting something up and down, vertically reflecting, what axis am I reflecting over? The x-axis. Very good. All right, peeps, our last one is what? That minus 3 at the very end, okay? Ask yourself, first of all, is it vertical or horizontal? It's definitely vertical. Why is it vertical? It's outside opposite world. What kind of transformation is it? Not a shrink. Kevin, you were going to say shrink too? It's not a reflection.
Stretch.
Not a stretch. Translation. Remember, what's another word for translation, guys? You could also put shift here too, okay? Either or. So it's a translation or a shift, and now we have to know where. Left or down? Why is it down, not to the left?
It's vertical.
Vertical. So it must be down. How many? 3. Yes, I know these are hard. There's a lot of rules to remember. We're at things like this. We practice, so we're going to do 2 more problems before we get started today. Yes. So we have exponential. We have 2 exponential functions. We have a growth one and a decay one. Guess what a growth one does over time? It grows. Guess what a decay one does over time? It decays. It downgrades. It gets smaller. Yes. No, he's not. Okay. All right. So exponential growth and exponential decay. We're going to start with the growth function. Okay. Now, the growth function, it is exponential, so it should have a what? What do exponential functions have? An exponent, right? Now, how to find your exponential function? It has like 4 different criteria, okay? It has this thing called the initial amount, which is your A. We've seen this letter before. Do you remember that number that we used to have in front of your base? That's just your A now, which is your initial amount, okay? Then we have 1 plus R. This is now your base, and the entire thing, we call it a growth factor, okay? 1 plus R. And then the rate of growth, how fast you're growing, is going to be this little letter R, okay? And then we raise it. Normally, we had X in this position, but now we have what letter? T. And that T is represented by time, okay? It's a standard exponential function, but in this case, this is the growth equation, okay? It's very, very easy to use once you get the hang of it, okay? But you do have to, if you want to star this, you have to remember and memorize this formula, okay? It's y equals a times 1 plus r to the t power. This will not be given to you on your exam. Okay, let's see it in action. Eli, what's up?
Is the 1 always going to be there?
The 1 is always constant. Very good. Okay, the 1 will always be there. Okay? All right, so let's see it in action. So in this first problem, okay, all we're going to do is we're going to set up the exponential growth equation for this problem, okay? It says the inaugural attendance of an annual music festival is 150,000. The attendance Y increases, underline increases, by 8% each year. Write an exponential growth function that represents the attendance after t years, okay? So first, let's start with our exponential growth function. It's y equals a times 1 plus r to the t power, okay? And by the end of this lesson, I guarantee you'll have that memorized, okay? We're going to use it a lot. So now, a, we don't know, but we can figure it out based on this problem. It's whatever we started with. How many people did we start with? 150,000. So write that as A. That's what we're going to plug in for A. 150,000 people. And then year after year, are more people or less people attending the music festival? More, because it says it what? Increases. Now, it increases by what rate? 8%. So guess what R is? 8%, okay? Now, we cannot use this formula when R is a percentage. So we have to change that into a decimal. Do you guys remember how to do that? It's 0.08, okay? What did Nathan do? Move the decimal where? 2 times to the left, okay? You move it 2 times to the left. In other words, divide by 100, right? And you get 0.08. Guys, all we have to do is plug in R, plug in A, and we're done, okay? So Y equals, what is A replaced with? 150,000. Go ahead, Natalia. What is R replaced with? 0.08. And then we raise it to the T power. There's only one more thing to do because we can simplify this a little bit. Do you guys know what 1 plus 0.08 is? 1.08. So Y equals 150,000 times 1.08 to the T power. That's all we're doing today, guys, okay? This is an exponential growth equation. It's a function, okay? Now, what this is saying is we could plug in any value we wanted for T. T represented what again? Time. And that would tell us how many people were there after that amount of time. So in 10 years, we would plug in 10 for T. You'd raise 1.08 to the 10th power and then multiply it by 150,000. You'd get your answer. Gabby?
You don't ever have to solve it, right?
No, we're not going to solve this, okay? This is what I'm looking for on the exam, okay? All right, now we converted this really quickly, okay? I just want to make sure we're all on the same page. So can you guys go back up? There's a few pink questions written for you. Can you guys convert either from percentage to decimal or from decimal to percentage? Try to do all 8 of those really quick and then we'll compare. Go. All right, let's go over these. What was 3% as a decimal? 0.03, very good. What was 41% as a decimal? 0.41. What was 35%? 0.35. What about 150%? Yeah? 1.50 or 1.5. Okay, very good. Are we proficient at this part?
Yeah.
Excellent. What about the reverse? How do you change 0.01 into a percentage? 1%. You move the decimal 2 places to the right. What about 1.37? 137%. Very good. What about 0.12, Kyle? 12%. And then 0.0003. Nathan? 0.03%. Very good. How'd we do? Did we get most of them? Kind of? We got all of them? Perfect. Okay. All right. So I want you guys to read letter B, cross out like this part of B, and I want you to try to do part A, which says write an exponential growth equation, okay? I want you guys to try to write one on your own. Use that same exact process we used for letter A, but try it on the second example. Go. Okay, your answer's on the board. Check it, talk, 30 seconds, go. People, all iPads face down. I don't want to see your screens at all. Benny, don't smile at me like that. It's a little weird. Okay, let's go. iPads face down. Let's go. Eyeballs up here. Miguel, pick your head up. Let's go. Okay, so what is 1.15 as a percentage?
115.
115%. Do you guys agree? Okay, now check it out. If I were to tell you that I had 100% of the same students that I have this year, that I have next year, would I have all of you guys next year?
Yeah.
Yes. Yeah. Now, what if I told you I had 115% of the students I had this year that I have next year? I would have you guys and more?
Yeah. Yes.
So do you see how I just grew in class size? Okay. If I told you you were going to grow 120%, you would grow as much as you have, so you'd stay the same size and grow an additional 20%. Do you guys agree? This is called the exponential growth equation, okay? So if this number is larger than 1, in other words, greater than 100%, you're growing. Do you guys agree with that? So what this equation does is it says, okay, we're going to grow 15% every time, however long time elapses, right? So if it's 5 years, correct? You take this number and you multiply it by itself how many times if t is 5? 5 times, right? So you keep growing and growing and growing and growing. Do you see how it exponentially builds on itself? This is a very, very useful equation, not just in math, but in life. Because interest, credit cards, everything kind of compounds on itself, and this is how we calculate it. So exponential functions are very, very important, okay? Now, I have a question for you. What would happen if this base was 1? If I take 1 and I multiply it by itself, let's say 10 times. In 10 years, what happens to the number 1? Stays the same. So if this base is 1, does this number change at all? No, so you're saying that you're going to have 500,000 people no matter how much time elapses. Does that make sense? So 99 times out of 100, guys, this exponential growth or decay problem will not have the number 1 there. Because then it's neither growth nor decay. It's just like a straight line. It won't increase or decrease at all. If this number is less than 1, let's say you only get 90% each year. So every year I lose how much percent? 10%. Am I growing still? No, what am I doing? Decaying. So if this number is less than 1, it's going to be an exponential decay problem, okay? All right, let's look at the iPads again. So that leads me to the exponential decay function. It's the exact same function, but who can point out the difference in the function? What's the one difference? Mariana? It's subtraction. Circle it, guys, okay? The only difference is you're going to subtract the rate of decay. So whatever your R value is, you're going to subtract it then from 1. So if you were decaying 5%, you're actually you're going to have 95% the next year. Do you guys agree? Yeah. So it would be 0.95 as that base, okay? All right, so the next thing that we're going to look at is we're going to look at what it looks like in a table, okay? So check out example A. We have to determine, okay, what are my X values doing? They're going up, right? By how much? 1 each time. What are the Y values doing, though? They're going down by how much? They're being divided by 3. Now, you guys agreed they were going down, correct? It's clearly exponential because it's division or multiplication. But is it decay or growth? This one's decay. Because they're going down. You with me? Okay. Now, a little hint for you guys. Anytime you're dividing each of your numbers, it's going to be decay. Anytime we're multiplying, guess what it's going to be? Growth. Okay? So let's check out example B. What are my x values doing? They're adding by 1, going up by 1, going up by 1. What are my y values doing? Ah, they're being multiplied by 2. Good, Sansia. So if they're being multiplied by 2, exponential growth or exponential decay? This one's growth. Easy?
Yeah.
Good. What about C? My x's? My x's? Adding 1. My y's? Good, they're dividing by 4. Excellent. Growth or decay here? This one's decay. Why is it decay? It's going down. We're dividing, right? Okay, now the last one tends to throw a few people off. Well, let's try to take it piece by piece. The x values. They're going up by 2, right? So plus 2, plus 2, plus 2. The y's, they're adding by 7. So it's growing, right? Is it exponentially growing now? What does exponential mean? Multiplying or dividing. So what kind of function is this? This one's linear. Very good. Are linear functions exponential? No. So what do we put here? This one's neither. Okay? Because it's neither exponential growth nor is it exponential decay. You guys said this one was linear. Okay? If you put linear and you don't put neither, it's fine as well. Okay? All I want to know, though, is was it exponential growth or decay? And it said if it wasn't either of those, then just put neither. Okay? Are we Gucci on these? Yeah. What if it was subtraction? What would we put?
Neither.
We would still put neither because that's still not decay, right? Exponential decay is when you're dividing. Okay? All right. Last few examples and then we're done, guys. Okay? I told you it was easy. Okay? Check it out. So we're going to interpret exponential functions. Given the function, we're going to be able to determine, okay, is it growth? Is it decay? What is the rate? Okay? So take a look at letter A. I told you if this number as your base, you don't care about the 5 right now. That's your starting value. I care about the base. If it's larger than what? It's growth.
1.
If it's larger than 1, which equates to 100%, right? Is this larger than 1?
Yes.
Yeah, so it's exponential growth. Now, how much is it growing? What is the rate of growth? 0.07, right? So how you calculate it is you do 1.07 and you subtract, guess what? 1. What do I get when I subtract 1? You get 0.07. Always convert it to what? A percentage when you're talking about the rate, right? So our rate is what? Is 7%. That looks like a 70. That's not supposed to look like a 70. That's a 7%. Questions? Comments? Concerns? Josh?
Why do you turn it to 2%?
Why do I turn it into a percent? Because I don't want to say that my rate is 0.07. Typically, we say that our rate is 7%. Okay? All right, B. Why is it decay? It's smaller than 1. How much smaller than 1? 0.02. So check this out. For decay, you do 1.00 minus 0.98, right? Find out how much smaller than 1 it is. And what do we get here? 0.02. In other words, what's the rate of decay? It's 2%.
So you do what's in the parentheses?
Correct. Do I care about this 0.2? Not really, right? It is contributing to my function, right? but it's just my starting value. So I started with 0.2, and then I'm decaying by 98% each time, okay? Yes, you may. Okay, I want you guys to try C and D on your own. These are the last two examples of the lesson. Go. C should have said decay with a rate of 8%. And this one should have said growth with a rate of 20%, okay? I want you guys to literally cross out example 4, and I need you to cross out the solving real life problems, example 5. We're gonna cover interest at a later date. And then I do need you to answer this exit ticket. I feel really good about blank. Tell me what was the best part of the lesson for you? What made the most sense to you? What you understood the best? It is completely up to you. There's no right or wrong answer here. Answer that and then turn this in.